This is known as the fold nose. The fold nose. That's this problem. It's called the fold nose. And it is done on an 8.5 by 11 inch sheet of paper. All right? And here's how it works. And what's crazy about it is you can get a pretty good guess to what the answer is if you just have a ruler and paper. Now, 3 corners stay put. They don't come off the board. They stay put. But when you lean it over, this corner right here has got to touch the other side somewhere. All right? Now here's what I'm going to show you. I'm just going to do this. If I touch right there and I measure the fold, that's what we're going to measure. Everything we're going to talk about is the fold question. Well, if you measure this one and you got a ruler that's, make sure, and we're going to do it in inches because it turns out these pages are all 8.5 by 11. Okay, so it actually is nice because you can test it with your page. But if you go here and you measure that fold, I am at 11 and an 1/8. That's an 11 and 1/8 inch fold. Okay, now someone says, Mr. Evans, I'm going to fold it up this way really far, like so. Try to do it a little bit different. And I'm going to measure that fold. And if I measure that fold, I'm up to 11 and 1, 2, 3/8. 11 and 3/8 fold. And maybe if I fold it way down here, trying to get like there. Remember that corner's got to stay on the board, so as close to that corner as I can get. And I'm going to measure that. That's 11.5. It's not quite 3/4, probably 5/8. 11 and 5/8. Pretty close guess. And then, of course, I've been trying to get it real low. Let's see what happens if we try to get it way up there. Like that. And I measured that one. Wow, that one's 11.5. Can't believe that's 11.5. I mean, that's just perfect. 11.5. But the whole catch is, we want to know what is the shortest fold. What's the shortest fold that you can get? And notice as I've done this, we're getting a lot of numbers, right? So if you want, you can kind of work together at your desk, or you can come up here and use one of these pages that I've already done, and you can bend it some more and measure. And that's basically what you do, is you just go out, bend it, measure, try it again, and do what? Measure. Say, oh, I'm going to go a lot lower and measure. But if you start doing it, you start measuring, see what you get. And you can do it in pairs if you want to, if it's easier for you. One of you to fold it, one of you to measure. However you want to do it, but see how close. See what you get is what the shortest fold is. And if you want to do it at the board, you can, or if you want to do it there. If you want to do it at the board and tape it up on the board, you can. If you want to put your new page up there and tape it up, do you want to do that?
I'm good.
So the bottom corner has to touch the other side.
Yeah, and that corner has to touch the other side. And 3 of them have to stay flat on your desk. And you can take them down if you want to. I got some tape. I probably wouldn't do that. It's kind of a pain, but if you want to take them down, you can. Yeah. and then just measure. You know, you got to fold, measure, and see what you get. And just kind of write down the different measurements you get, and we'll see if y'all can come up with what y'all think is the shortest fold for this. Ooh. This is good. I got students actually taking part and folding the page.
They just want to work together.
Yeah, fail everybody. Yeah, Reese needs help.
11 and 1/16, that's the shortest.
Yeah. It's not, but sorry.
Pretty
Is it
close.
11?
11?
Yeah.
Close.
Ooh, actually, I'm at 11 too. So. How would we make this shorter? Probably.
Yeah, that's what you start doing. You start going, ooh, uh-oh, that made it get longer. Oh, that made it get shorter. And sometimes it's not what you expected to happen. I have that problem when I look at it.
Okay, so if you go at a perfect,
And I will tell you, it's not a 30-69 triangle. And you know, somebody always guesses that. And I don't have a problem with that. 'Cause, you know, you expect it to be something from geometry. You go, oh, it's a 30-69. It's not.
oh yeah, it's still fine.
Mr. Doe, what are you coming up with? 11 point
Like 1, 1/8.
an 8? 11 and 8? What? Some of y'all
This
get
is about this is
11 and 8? Reese, what you got?
this is not how this is supposed to go.
How close? What do you have?
No, it's not going to be 11. It's going to be something like 4, and you're supposed to bend it. a different way
Nope.
or something.
No, it's not any of that
It's nothing like
GT
that.
math. No.
It's nothing weird.
No, it's not GT math.
So it's not like you roll it up on it.
No. The rules are the rules.
No?
I did it exactly how you have to do it. Yeah.
Mm,
I'm not trying to do any of that.
yeah.
Let's let the children play and expand their brains, GT math. No, we're talking about real math. I shouldn't make fun of GT math. It is good for y'all. They'd make y'all learn some rules, memorize rules, and free think.
11 1/4.
So I.
Yeah, you could fold it exactly right there,
Yeah.
right?
I already did that. It was really long.
Well, how long is it?
It's 12 inches.
Yeah, it gets really long. Okay, so we don't want to do that. Somebody said, Mr. Evans, you don't want to do that, even though that would fit the rules, because that would still be, that point would still be there, because that turns out to be really long. And it doesn't look like it, but it is. The paper fold. Only the shadow. Oh, wow, it's 12 something, isn't it? 12 plus. Don't be mean to the children. You don't mind being on video, do you? See, right there, you got your page. Oh, you don't want to be on video? And there's Reese
Yes, I
back.
don't mind.
And Reese is back there working too. See, got the fold. Only the shadow knows. He's only got 5 people in his class. You'd think this was a GT class. All right. Any thoughts?
Sure it's not
I'm
11.
thinking there's something else to it.
11. Do you keep getting real close to 11?
Yeah, just keep getting 11.
You keep getting exactly, oh, wow, okay. Miss Sullivan thinks it's 11. She's going 11. Sullivan, that's right, right?
Mm-hmm.
I only have 5 children, don't know their names. She's thinking 11. What are you thinking, Reese?
10 and 15 sixteenths.
Ooh, 10 and 15 sixteenths. Why are you thinking that? You just making up something close to 11, or you really think that?
I'm making something up.
Yeah. Is it time to laugh at Mr. Courtney?
I keep getting 11.
You keep getting 11 too? Okay.
Yeah. Yeah, I'm getting 11 too.
All right.
I can get under 11.
Well, you know what? If you lived in a pre-calculus world, 11 would have been a real good guess, but it's not right. Okay?
30,
But 11 would be a good guess. What was that?
10 and 31 30 seconds.
Ooh, man, saying, oh, it's just under 11.
Yes.
1/30 seconds.
Yeah, 31 30 seconds.
Oh, let's see. I don't know. All right, well, you notice Mr. Evans is getting the board ready. Because here's what we're going to do. Hang on, I'm going to give you a fresh sheet of paper. So that you can just put one fold in. That way you'll have something that's nice and neat and easy to work with. Take this sheet and that way you can just put one fold in. The man is marking it off. Yeah, keep that sheet. Give that to Reese. Here you go, Mr. Doug gets sheet. This way you'll have one sheet to actually fold at one time, and even though it's not probably going to be folded exactly where you want it, it'll just help you with the problem to have a sheet to fold. Okay. And we want the shortest fold. So what we're going to do is we're going to talk about how you could calculate it to the exact value. See, we've done a little experimental work. That was the experimental work, and now we're going to see if we can get math work to come out to be pretty close to what we think the experimental work is. And to do that, Mr. Evans is going to need lots of room. And he's got to write really small, which he has trouble doing that. All right. And we're just going to fold it, and I'm going to give you some hints on what to do. All right. And I'm going to have my work page right here. I'm going to try to write it on there big enough you can see it, or big enough that the guys can zoom in if they're doing it at home. All right. What you can do is you know the dimensions of the page, right? It's 8.5 by 11. And I really don't even want to write that up there because it's just getting way for what we want. All right. Now, if you take the page and you do what we were talking about doing and you fold it over, and I'm just going to fold it over. I'm not even going to try to fold it at the shortest place. I'm just going to fold it so I can look at the fold. All right? Is that okay? I'm going to give you a hint about what to start with. See this distance right here? See that part? That distance right there? Call it X. That's X from there to there. Which also means after you fold it, what's the distance from here to here where I'm holding? That's still going to be what? X. Is that cool? Now, what we're also going to do, just to make everybody on the same page, we're going to make this part over here Y. Which means that if you fold it up like this, this is equal to how much? Y. Oh, and right here's our what? Fold. And just to make life a little bit better, so we'll all be talking about, if we call that theta, then how much is this? It's still how much? Theta. And what you want to do is write an equation that says fold equals. I wouldn't do it on my blue sheet of paper. I'd start thinking about how to do that on my other sheets of paper. But start thinking of an equation that will say fold equals. And there's one equation that better jump into your brain pretty fast. Or you might just want to write what the fold squared equals. We'll put me a little piece of tape there and hold it. Because see, if I know that's x and y and that's theta, it helps me here because then I can see my fold, right? Tell me, what does the fold equal or fold squared equal? Come on, this is not a trick question.
Pythagorean theorem.
Yeah, yeah. Hey, folks, the fold equals x squared plus y squared. We will minimize the fold. Minimize. Does that have an E on the end of it?
Mm-hmm.
Minimize the fold. Okay, someone said Pythagorean theorem. So the fold squared equals x squared plus what? Y squared. Now, how did you minimize or maximize in your AP Calculus class?
Optimization.
Optimization. How'd you do optimization?
You get like 2 formulas instead of 0.
Yeah, you got to write a formula for the fold in how many variables? 1. You can only have how many variables over here? 1. So you have to write a formula for the fold in one variable, take the derivative of that, and then do what? Set it equal to 0. Is that okay? Well, folks, that's the calculus. In other words, after you write this formula for fold in one variable, you take the derivative. Okay, start coming up with a way to write all that in terms of one variable. You've either got to change x's into y's, y's into x's, or figure out some other way using trig to write those. And notice I put the theta in there to help you, didn't I?
Use tangent.
Tangent theta would be what?
Y over x.
Tangent theta would equal y over x. So that does tell me that y would equal what? X times tangent theta. Which is kind of cool because then I don't have y's anymore, I got x's and tangent thetas. I'm going to tell you that's a good step. Alright? What might I tell you now? If I knew what x was in terms of theta, if I knew what x equaled in terms of theta, I could put it right in there and then I'd have y equals everything in what? Thetas. And if I already knew what x was in terms of theta, I would actually rewrite this. What you want to do is you want to get the x in terms of theta and the y in terms of theta. That's what you want to do. And you want x as a function of theta. X of theta. X equals a function of theta. That's what you want. Now, that's not as hard as you think. If you were going to do that, do you agree that you don't want x with y's, you want x equals something that's only thetas, right? All right, I'm going to ask you a question here. Okay, that's x right there, isn't it? Right? Now, when we were doing that, did you... About to mess up my corner. Don't want to mess up my corner. Did you notice what's the distance all the way across here? 8.5. So, what is this little piece right here equal to? 8.5 minus x. That little spot right there is 8.5 minus x. can you tell me what this angle is? And no, it is not theta.
Theta minus what?
90 minus theta.
Ooh, not 90.
Oh, wait.
And it's not 180 minus just a theta.
2 theta.
Yeah, because there's a, okay, theta, right? That's theta. Does everybody agree that's theta from there to there? And then when you fold it over, that's another theta, right? So that's what? 180 minus 2 theta. Now, if you do that, you can use 180, but it'd be better to put at this angle right here. That angle is really pi minus 2 theta. That's the angle. And the cosine of that angle would equal the adjacent over the what? Hypotenuse. And that way you can get x just in terms of theta. Now, I'm going to write that out a little neater. Matter of fact, I'm going to write it out real neat right here. Cosine pi minus 2 theta equals, I'm going to put 17 halves too. I can't deal with a mixed number much longer. 17 halves minus x over x. And that. What do you think I'm going to do to simplify that cosine theta minus 2, pi minus 2 theta? What am I going to do to simplify that?
Distribute it?
Can't distribute it. That's against the rules. It's not cosine times that, it's cosine of all of that. Can't distribute it. But there is a what?
Sure you guys do.
Yeah. You better have the unit circle with you when you go to calculus next year. This is not real advanced calculus. This is in the section on what? Minimizing and maximizing, which is really early in derivatives, right? So you better know the cosine of A minus B. Does anybody want to take a guess on what the rule is?
Isn't it like, if it's subtraction, it's like cosine pi
Pi.
minus, or plus sine?
How about it's cosine pi cosine 2 theta plus sine pi sine 2 theta equals 17 over 2 minus x over x. And once you get here, if you know your unit, notice you just had to use a what? Trig identity. Now, do you know what the cosine of pi equals? It's on your unit circle.
Yeah.
-1?
-1. So you'll get negative cosine 2 theta plus, what is